So today what we're going to be working on is graphing our rational functions. So we're going to be graphing the functions that are the fractions. Okay, so we kind of want to follow these guidelines here. So number one is going to be to find and plot the y-intercept, find and plot the x-intercept, find and sketch the vertical asymptotes. Remember, that's where the denominator is equal to 0, or any holes in the graph. Find and sketch the horizontal asymptotes. Find and plot the points between and beyond the x-intercepts and the vertical asymptotes. You cannot use a calculator for any of this. And then you're going to draw smooth curves between and beyond the asymptotes. So just one thing is, when you are graphing, you can cross a horizontal asymptote. You can't cross a vertical asymptote, but a horizontal asymptote you can. All right, so let's take a look at number one. Okay, so the first thing we're going to do is we're going to find our y-intercept. So remember, our y-intercept is where x is equal to 0. Okay, so I'm going to make y equal to 0 minus 2 over 0 squared minus 0 minus 6. So this is y equals 2 over 6, which is 1/3. So my y-intercept is 0, 1/3. Okay, the next thing I'm going to find is my x-intercept. Remember, that's when y is equal to 0. So I have 0 equals x minus 2 over x squared minus x minus 6. Put 0 over 1 and cross multiply, so I get 0 equals x minus 2. Add 2, x is equal to 2. So my x-intercept is 2, 0. All right, now I want my vertical asymptote, or I want to see if I have a hole. So I have to factor the denominator anyway. So x squared minus x minus 6, that factors and becomes x minus 3 times x plus 2. So there's no holes because my numerator is x minus 2, so that does not reduce. So that means there is no holes. All right, so my vertical asymptotes. So this is number 3. My vertical asymptotes is when the denominator is equal to 0. So I factor, I get x minus 3 times x plus 2 equals 0. X equals 3 and x is equal to negative 2. Those are my vertical asymptotes. Now I need my horizontal asymptotes. Right, so remember, you look at the degrees. So I have x to the first over x squared. So the degree of the numerator is less than the degree of the denominator. So that means my asymptote is y is equal to 0, because it means it's approaching 0. Okay, so let's see what we have so far. Let's start getting some information down here. Start graphing. Okay, so I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 4, 5. Okay, so let's see. We have let's get our vertical asymptotes. So our vertical asymptotes are at x equals 3 and x equals negative 2. And I have a horizontal asymptote at y equals 0. which is right on the axis here. Okay, so I know that my graph will cross at 0, 1/3. So that's about right there. 2, 0 is my x-intercept. And now I have to get some other points to plot. All right, so we're going to make a table of values. So I'm just going to move everything up a tiny bit. All right, so I'm going to make a table of values here. I'm going to have an x column. I'm going to have a y column, or f of x. And in the middle is going to be my function. So it's x minus 2 over x squared minus x minus 6. So I want some numbers to the left, in the middle, and to the right of my vertical asymptotes there. So I'm going to do here, let's see, -4 I'll do, -3, -1, I already have 0, 1, I already have 2, I'll do 4, and 5. Okay, so let's plug it in. So I have -4 minus 2 over 16 plus 4 minus 6. So -4 minus 2 is -6. Over 16 plus 4 is 20 minus 6 is 14. So it's -6 over 14. So -3 minus 2 over -3 squared is 9, plus 3 minus 6. So 9 plus 3 is 12, minus 6 is 6. So it's -5 over 6. All right, -1. So it's -1 minus 2 over 1 squared is 1, plus 1 minus 6. So that's -3 over -4. Which is positive 3/4. So that's positive there. Let's plug in 1. So I have 1 minus 2 over 1 minus 1 minus 6. So that's -1 over, I'm sorry, so that's -1 over -6. Okay, so 2, sorry, not 2, 4. I already have 2. So I have 4 is 4 minus 2 over 16 minus 4 minus 6. So that's 2 over 6. So 16 minus 4 is 12, minus 6 is 6. That's 1/3. And this is positive 1/6. And 5, so that's 5 minus 2. Over 25 minus 5 minus 6, which is 3/14. Okay, so now let's plot those points. And let's see what we got. All right, so I have -4 and -6 over 14. So that's going to be about there. And then I have -3 and -5, 6. Is a little down a tiny bit further. So that means this graph's going to look like this. And here in the middle, so I have -1 is 3/4. So which means it's going to look like this now. And then I have 4 is 1/3. 5 is 3/14. So that's really small. So it's going to look like that. And it'll go out like that. Okay, so that would be number 1. Let's take a look at number 2. Okay, so we have f of x is equal to 2x minus 4 over x. So let's start with the y-intercept. Just remember that's when x is equal to 0. So y is equal to 2 times 0 minus 4 over 0. That's undefined. So that means there is none. So you could put DNE if you want for it does not exist. Okay, so next thing is to find our x-intercepts. Remember, that's when y is equal to 0. 0 equals 2x minus 4 over x. Cross multiply. So I get 0 equals 2x minus 4. Add 4, divide by 2. I get 2. So I have 2, 0. All right, now I need my vertical asymptote, and nothing's going to reduce here, so there's not going to be any holes. All right, so my vertical asymptote is when the denominator is equal to 0, so that's x equals 0, done. And now my horizontal asymptotes. So I look at the degrees, so I notice that my degrees are the same. Right? So the degree of the numerator is equal to the degree of the denominator. So then that's just y is equal to 2. So when the degrees are equal, then it's y equals whatever your coefficients are. All right, so let's see what we have so far with our graph. All right, so I have 1, 2, 3, 4, 5. -1, -2, -3. -4, -5. 1, 2, 3, 4, 5. 1, -1, -2, -3, -4, -5. Okay, so let's see. We have no y-intercept. I have an x-intercept at 2, 0. And I have a vertical asymptote at x equals 0, so that means it's right on the y-axis. And I have a horizontal asymptote at y is equal to 2. Okay, so now what I'm going to have to do is make a table of values to find some other points. Alright, so I'm going to do some numbers to the left of 0 and some numbers to the right. So I'm going to use -4. And I'll use -3, -2, -1. Not 0, because I know 0 is, it's undefined there. 1. And I'm going to move this stuff up here. So I have 1, 2, 3, and we'll do 4. Okay, so this should give us a good idea. All right, so let's plug in the numbers. So I have 2 times -4 is -8. Minus 4 over -4. So that's -12 over -4, which is 3. Remember, no calculator for this. So 2 times -3 is -6, minus 4 over -3. So that's -10 over -3. So that's positive 3 1/3. 2 times -2 is -4, minus 4 over -2. So that's -8 over -2, which is 4. 2 times -1 is -2, minus 4 over -1. So that's -6 over -1, which is 6. 2 times 1 is 2, minus 4 over 1. So that's just -2. 2 times 2 is 4, minus 4 over 2. That's 0. 3 times 2 is 6, minus 4 over 3. So that's 2/3. And then 2 times 4 is 8, minus 4 over 4. So that's 1. Okay, so let's plot those points. All right, so I have -4 is 3. -3 is 3 1/3. So it means it's a tiny bit higher. And -2 is 4. So it's going up. So that means it's going to look like this. Okay, and so now let's get to the other side. 1 is -2. 2 is 0. I already had that one. I don't know why I did that one again. So I have 3 is 2/3. So it's a tiny bit higher than the x-axis. And 4 is 1. So that means it's going to look like this on the other side. That should go through that point there. Okay, so let's flip it over and take a look at the back. Okay, so take a look at number 3. So I noticed number 3, it looks like I'm going to be able to factor. So I want to factor this to see if I have any holes. Now remember, your holes are going to be when you have a numerator and the denominator are the same. Okay, where you have the same factors. So x squared plus 4x minus 5 factors and becomes x plus 5 and x minus 1. And x squared minus 1 becomes x plus 1 times x minus 1. So notice I have this factor here. This is the same. That means there's a hole at x is equal to 1. Okay, so we'll get to that in a second. So let's get our y-intercept. So let's start with that. That's when x is equal to 0. So I have y is equal to 0 squared plus 4 times 0 minus 5 over 0 squared minus 1. So y is equal to negative 5 over 1, which is 5. So then that's 0, 5. Okay, so that was the first one. All right, I need my x-intercept. That's when y is equal to 0. So I get 0 is equal to x squared plus 4x minus 5 over x squared minus 1. So 0 is equal to x squared plus 4x minus 5. That factors, and we already know what the factors are. So that's x plus 5, x minus 1. So it's x equals 1 and x equals negative 5. But I know that at x equals 1, right, there's actually a hole there. So that's not going to work, right? So that's going to be negative 5, 0 there. All right, so now I need my vertical asymptotes. All right, so that's when my denominator is equal to 0, right? So that would be x plus 1 times x minus 1 equals 0. But I know that there's a hole there. So at x equals 1, I have a hole. So you have to find the y value. So you take x equals 1 and you plug it into x plus 5 over x plus 1. So you get 1 plus 5 over 1 plus 1. So that's 6 over 2, which is 3. So my hole is at 1, 3. And I have a vertical asymptote at x equals negative 1. Now we need my horizontal asymptotes. So that's x squared over x squared. So my numerator degree is equal to my denominator degree. So it's the ratio of the coefficients, which is y is equal to 1. Okay, so let's start graphing. All right, so I have a y-intercept at 0, 5, so let's graph that. I know that I also have an x-intercept at negative 5, 0. So I also, actually let me be using blue here. I also have a hole at 1, 3. And I have a vertical asymptote at negative 1. And a horizontal asymptote at y equals 1. Okay, so let's make a table of values and find some other points. All right, so we have our x column. All right, so I have x squared plus 4x minus 5 over x squared minus 1. So I'm going to go from negative 4, negative 3, negative 2, negative 4, negative 3, negative 2. I'm not going to do negative 5 because I already have negative 5. I need 0, 1, 2, 3. I'll go 1. Okay, so now let's start plugging it in. So I have 16 for the first one. 16 minus 16 minus 5 over 16 minus 1. That comes out to be negative 5 over 15, which is negative 1/3. The next one is going to be 9 minus 12 minus 5 over 9 minus 1. So that's going to be 8. So that's negative 8 over 8, which is negative 1. So the next one is going to be 4 minus 8 minus 5 over 4 minus 1. So that's negative 9 over 3, which is negative 3. 0 plus 0 minus 5 over negative 1, so that's just 5. So remember at 1 I had that undefined piece in here. Right, so when I plug that in I get undefined. So actually let me show you that. Okay, so I have 1 squared is 1 plus 4 times 1 is 4 minus 5. And then it's 1 squared minus 1, which is 0. So that's undefined. Okay, so I'm not going to do anything with that. The next one is 2 squared, which is 4, plus 8 minus 5. Minus 5, sorry. Divided by 3. So that comes out to be 7/3. So that's about 2.3. And then 3 squared is 9 plus 12 minus 5 over 8, which is 16 over 8, which is 2. Okay, so let's plot the points. So I have negative 4, negative 1/3. And then I have negative 3, negative 1. And then I have 2, negative 2, negative 3. So you can see what's going on now. So it's going like this. And over here I have 0 is 5, 1 is undefined. 2 is 7/3, which is 2 point something, right? So it'll be about there. 3 is 2, so it's going to look like this. So make sure you don't go through that hole. And it'll go up like that. Okay, so that's it. I know it's a lot to take in. So we'll practice in class tomorrow. Have a good night.